Hi everyone, my name is Yap Wai Hong. Today with my teammate Paolo and Jian. We came from a DFT Year 2 Sem 3 Group X students. Today we have a presentation about the AACS2034 Fundamentals of Computer Network Assignment. Before I start my presentation, I would like to let you know about that our presentation is being separated to two parts, which is part 1 and part 2. I'm going to in charge in the part 1, which going to present the introductions, scenario, network topology design, and subnet table, while the rest will be going to present it by my teammate. In a scenario, we are being hired as a network engineer by the New Millennials University to design and set up a LAN network for the university with a building in different location. So based on the scenario, actually you can see that we have a location A and location B. So in the different type of location, they actually have a different department in a different flow. And also they have a different number of hosts being required. And they are actually far away between in a distance of 100 meters. So our design must be calculated the number of address needed for 55% growth in all area. So this is how the network topology being looks like. The left side actually is being indicate the location A, while the right side is indicate the location B. So the most top indicate the upper floors, which is the third floor, while the bottom square here actually is indicate the lower floor, which is the ground floor. So this is how the location A, each of the department being looks like, is interconnected with the switch. And this is the how location B being looks like. So as you can see, the location A has a 5 department and location B have 4 faculty. So in the intermediate device for the router, we have using the router PT empty. It's because it's provide more flexibility for the manually insert the port we want. So in the port, actually we're using the PT router and then one CGE. It's because it provides a gigabyte Ethernet connectivity. It's more faster for the router and it's interconnected between two locations, which is the location A and location B, provide more faster connectivity. While we also have using the PD router NM cover, which is to protects the internal components. And for the switch, we're also using the switch PT, and we have using several port. First, we're using the PT switch NM1CFE, which is provide the fast Ethernet connectivity for our end device, such as the PC and so on. And for the PT switch NM1CGE, we're using for the gigabyte connectivity, which we're using for the switch connected to the router. And we're also using the PD switch and N1 cover protect the internal components. And the end device actually we're using a very easy, which is a PC and server. While the transmission media actually we're using a copper straight through for all the connectivity. It's provide stability and reliability for the LAN network. And the for growth table, actually, as you can see, we have a subnet table here with a department. So based on the growth table, we need to calculate the 55%. So we take a 400 of the requires the before growth, which is 400 of hosts being required, and we time it with 55%, you get a 220, and sum it together, you get a 620. So the rest actually calculations method is almost is the same. And this is how the subnet table being looks like. We have a subnet number, department name, number of hosts required, maximum host, minimum host, network address, site block, first usable, last usable, broadcast address, range of address, and usable IP. So the IP address we use is a 10.0.0.0. It's a class A, while the subnet technical actually using the fixed subnet length mask FLSM known as a class full. So as you can see, our site block and the range of address is the same. So the subnet method actually using the number of hosts per subnet, while the number of bit required to the host is 10 bits. So the number of hosts is 2 power of 10, you get 1024. Now the question, why we cannot using a 2 power of 9? It's because that 2 power of 9 is 512. So it's not enough to accommodate the sensory department. As you can see, the sensory department is requires a host about like 620. So when we want to calculate the number of hosts, we need to find out the most bigger, most larger host required in overall department. So the sensory is the most bigger, 620. So the number of usable address actually using a number of hosts minus with 2. The 2 actually is a reverse bit, which is a network ID and a broadcast address. So you get 1022. And the number of subnet actually using a total of bit, which is 22. So total of bit here is meaning that the IP address. So as you can see, one portion of the network and the three portion of the host. So one portion in here actually is represent as 8 bit. So here has a 4 portion. So 8 times 4, you get 32. So and 32 minus with 10, you get 22. Site block actually is based on the subnet, so /22. While the subnet mask actually is also based on the subnet. So subnet and it convert back to the binary digit. So 255.255.252.0. So actually it's here. 8 plus 8 plus 6, you get 22. So, and then the maximum host actually using the 2 power of 10, which is the 1000 of 22. So here actually is almost is the same as a number of hosts. And the minimum host actually using the bit that you borrow and the previous one, which is the 2 power of 9, and you plus 1, you get a 530. Now talk about network address calculations. So as you can see here, subnet table actually we have a calculate all the network address. So how we calculate? So using the IP we use it and identify how many hosts we borrow, which is 10 bit here, and you draw a straight line here, and starting with 0, 1, and then 0, 1, and 0, 0, 1 is same as the binary. So the 0 here actually is in the first line here is indicate the first subnet. So 0 is indicate the first network, which is 10.0.0.0 until where. When you need to identify it until where, you need to know about the second subnet. So second subnet here will become 1. So take the value here, 4 in the third position. So 10.0.0.4. So now you know about the first network here is until the 10.0.3.255. The 255 is the maximum of the IP in one position. So the rest also using this way to calculate. So now we already calculate the network addresses, which is here, and the broadcast address. So how we identify the first usable, which is using the network address plus 1, while the last usable actually using the broadcast address minus 1. And the range of the address actually is starting from the network address until the broadcast address, as you can see here. While the usable IP actually using the first usable until the last usable. So that's end of my part. Now I'm going to pass to my teammate Paolo.
Hello, my name is Paolo Jian from Diploma in Information Technology, Year 2, Sem 3, Group 8 in Thai UMT KL branch. I am the second presenter for this assignment AACS2034, Fundamentals of Computer Network. Today I will be presenting the addressing table, configuration command use, and the ping command. Next slide. As a start, I am going to present the addressing table. In this slide, we can see the interface, subnet mask, and the IP address assigned in the addressing table. All this information is based on the topology we created. As you can see, the interface Gigabit Ethernet 0/0 has been assigned with the IP address 10.0.06. For the Chancellery Department, the interface Fast Ethernet 0 for PC10 has been assigned to the IP address 10.0.0.2. Here are other addressing tables for other departments and faculties. Due to time constraint, I will skip this part. Next slide, network configuration. Both of these commands can be used by router and switch. So to set console line password, we must remember to type line console 0. After accessing the configuration mode, we can perform two tasks, which is to set the privilege mode password and secret password. In this slide, this table will be the command to set the IP address and default gateway for switch and router. For router, you have to set the IP address and subnet. Additionally, for switch, you have to set the default gateway. See right here. For the next part, I will show you the device ping connectivity by using Cisco Packet Tracer. In this example, I will use PC1, which is the IP address of 0.0.8.2, to ping with the same location, which is location A, PC4, which has 0.0.12.2. So we're going to go to the command prompt and ping the exact IP address given by PC4. We have one request timeout, which causes 25% of loss. We will try that again. So for the second time, we get 0% of loss, which is considered successful when transferring data. So I will use the same PC1 again to transfer to others PC from other location, which is location B, 10.0.16.2. which is considered successful. So that is all for my ping part. So during the accomplish of this assignment, we have used Cisco Packet Tracer, YouTube, Facebook, Google Slide, OBS Studio, and many more. Last, that will be the end of my presentation. Thank you.